Now we need to do a few fixes to the paddle. In order to add collision to the paddle, we need to add the same logic we did to the bricks. First of all, we need to add the registration point to the paddle so that x0 and y0 values of the paddle will be the exact middle of the paddle. So we're going to add the paddle registration x as half the width of a paddle and registration y as half the height of the paddle. We've added the getBounds function here. As you can see, we're testing it in the check collision. Now when you test a general element and ask for the getBounds function, it's supposed to give us the rectangle of that hit element. Now this rectangle is not part of the Create.js framework. We need to add it manually. Every time we want to test the bounds of a certain element by using the getBounds, we need to make sure that we set it beforehand when we created that element. So we're going to set bounds of the paddle. We're setting the middle point, which is the paddle registration x and paddle registration y. And then we set the width, which is the paddle width, and the height, which is the paddle height. Now by using the setBounds, we'll be able to use the getBounds in the future and get the values like the width and the height. We're going to do the same to the brick itself. So we're going to set its bounds and brick registration x, brick registration y, brick's width, brick's height. Now, when hitting the paddle, the return angle of the ball should be determined according to the location on the paddle in which the ball hit. Because unlike hitting a brick, let's say we hit the brick at the bottom, so the y direction should be reversed. And if we hit the brick on the right, then the x direction should be reversed. In the paddle, the return angle should be determined according to the location on the paddle in which it was hit. Let's say the ball hit exactly in the middle of the paddle. The x speed should be minimal because it's the exact middle. So can't return to the right or to the left. We hit the middle, so we're just going up. So the y speed is the main element here. But if we hit the paddle in the right or in the left, then it should return according to the location it was hit in the paddle. So we're going to add a new function called newBallXSpeed after collision. Here we're going to get two variables, ball element and hit element, and we're going to set a few variables which are the start point, the midpoint, and the end point of the hit element. The hit element in its specific use will be the paddle. So we're going to test if the ball element hit on the left of the midpoint, then the ball should continue to the left. So the ball right value is false, and the ball x speed should be determined according to the location in which it hit. So we're going to add a new variable called fullSpeedX. And we're going to test. Now if you take a look at the x speed, we're going to take the 7, which is the absolute value, and we're going to take a percentage off according to the location where the ball hit. So if the ball hit closer to the middle, then this equation will be equal 1 or closer to 1. And then 1 multiplied by full speed will give us full speed, and then full speed minus full speed will be 0. So this equation gives us the percentage of the speed which we'll have after the ball hit. So this is once we hit the left part, and this is once we hit the right part of the paddle, which we have a similar logic. We take the full speed and then check the endpoint according to the middle point to get the exact percentage that we need to add it to the full speed. Now, last but not least, we need to remove the brick itself from the screen after we completed the animation. So we're going to add a new function called remove brick from screen, and we're going to get the brick as a variable, and we're going to use the stage remove child to remove the brick. Now, since the animation of destroying the brick is 500 milliseconds, we're going to set a timeout for removing the brick from the screen for 500 milliseconds, and we're going to send the brick, which we just removed, as a variable. Last but not least, we're going to change the X speed and the Y speed to default values of 5. Now we can test the new game. As you can see, the return the ball returns according to the hit in the brick, but we still can't see the ball hitting the paddle itself. Now, why is that? It's because we haven't added the collision test to the paddle itself. If we go to the tick function, after we've destroyed the brick and we've checked everything, we need to check the collision of the ball and the paddle. If the ball and the paddle collided, then we can change the ball speed using the function we've created earlier. So let's take a look at the game again. As you can see, now when it hits the paddle, it reacts exactly like we coded it to be, meaning that we have a new X speed according to the location where it hit the paddle, and as you can see, the physics is very accurate. We don't see any elements overlapping. We see whenever the ball hits something, it returns to the natural direction it should go to, and basically the game runs perfectly. Congratulations! Now your game has a physics engine. In the next video, we're gonna add the scoring system.